principal retires because he or she. When a principal retires because he or she are already old, and a new principal comes in, this is a kind of exogenous variation. But I guess that most of the times when a principal retires is because he or she are doing not a very good job. So this is an endogenous issue.
So I mean, this is a real complication for us. So it's not a complication just to say, so someone's doing a poor job and then they're replaced by someone else, because in some sense that's what we're trying to look at. I think that the complication really arises when two things. It appears from some research that a graduate student at Princeton did that when someone knows they're going to leave at the end of the year, they do much worse in that last year. So one of the things we could be picking up is the difference between this kind of end of your time at your job versus the next person coming on. I think the other thing that we worry about with this endogeneity of the principal changing is that there's other things going on at the same time. So it could be that the neighborhood is changing. It could be that the governance of the school system is changing, and they want to remove the principal and replace the principal with somebody else. There's lots of things that could be changing along with the principal. So we would really love to be able to have exogenous changes in principals. Retirement would be great. We don't know here if someone is retiring or not. We can look at schools in which the principal has worked in the state for over 25 years and just assume when that principal leaves that they're retiring, or that change is more likely to be exogenous. And I think that's a great suggestion, and that's something we need to do. Yesterday at the seminar, they had talked about that there's some papers that look at the political process, and they look to see if political leaders are important, and they look at assassinations, you know, as being a kind of exogenous shock, which may or may not be true. And then they go further and they compare places where there's attempted assassinations, and you compare the places where they succeeded versus the place where they didn't succeed, the idea being that you're having the same kind of shocks. So I don't know that we have something similar with principals, but I think that's really a big problem, that there could be other things going on. I don't mind the fact that somebody's bad and they get changed and then you get somebody different, because in some sense that's kind of, you know, what we like. I think the bigger problem would be someone is bad and they're allowed to be bad under the old regime, and the new regime comes and says, well, this principal's not very good, we're going to change her to a new principal, and we're also going to do these other things in the district that change the education. So that's certainly a challenge for us. Okay, so there's potentially bias even when you control for these fixed school characteristics if there's other time-varying factors that aren't accounted for. Now, these tests in Texas, they're very different than tests like PISA or the National Assessment of Education Progress in the state's NAEP, which are tests that try to get a broad range of questions, some which are more higher skills, higher level skills, some which are more lower level skills. These tests in Texas tend to focus on lower level skills, at least during this period. And so there's one problem in a lot of education research, is that the tests are noisy measures of the kids' knowledge or how the quality of the school. The school may do a very good job teaching spelling, and this is just an example. There's not spelling on here, but imagine the school teaches, there's a bank of 1,000 words. The school teaches the kids 900 of them, one school, and the other teaches the kids 500. But it just so happens out of the 20 words that are on the test, the school that taught 500 actually taught more of those words than the school that taught 900. And so you can have this sort of random error. Kids can be sick around the test date in some schools just because that happens to be the time that these illnesses are going through. So there's lots of things that are going to introduce random error. And we use Bayesian shrinkage, or we try to adjust so that you weight more heavily the schools that seem to have more precise estimates effect of the principal. But we also worry that this focus of the tests on lower level skills is going to distort the contributions of principals. And think of an affluent school that have many more of the kids are high achievers coming in because they've had many more access to education resources growing up. And let's say many of those kids could answer basically all the questions right the first day of school. And so that school is focusing on a higher skill level of material that's never tested. And you might find that those principles have really little effect on, that they're not very effective in raising achievement, when in fact that would be very a distorted measure of the quality of those schools and the work of those principals, since they're really working very well to get the kids to learn skills that are advanced to that grade level. And so what we do is, if you look at this, is we take how well, if you're thinking about 5th grade, we look at how well the kids did in 4th grade, and we put students into 10 different bins or cells on the basis of where they fell in the distribution in 4th grade. And for each principal, we take all the kids in her school, and we see how much each kid learns relative to all the kids in the state who started in the same place. And then your estimate of your quality as a principal is how well on average you did with your kids in comparison to where those kids started in the state relative to all the other kids in the state who started at the same place. And we basically weight each of those 10 cells the same. So we eliminate, in a kind of artificial way, the differences due to the fact that some schools have lots of kids who start very low and some schools have very few kids who start very low. So I know it's a little confusing just to think about. It's actually become very popular in the US, and a number of states comply with the federal accountability law by doing exactly this. They measure each kid's growth in achievement from year to year relative to other kids in the state who started at the same place. And then you can compute for each teacher in many of these data sets, on average, how well did their kids do relative to the other kids in the state who started at the same place. So that's what we do in order to make sure that these test complications aren't driving our results. So let me now take some time and present to you the results. So if you look at the first column in the first row of 0.21 says that when we put together the distribution of principal effects, if you move one standard deviation, or say from the median principal to the principal in the 83rd percentile, so you go by 1/3 of the principals, that would tend to increase student test scores on average by 0.21 of a standard deviation. So I think in the old education literature, this would be considered a small effect. But for those of us who've been working for, more recently on all these education issues, and particularly on these estimates of the variation in teacher quality, this is a giant effect. So typically, the compelling studies of the variation in teacher quality find that if you move up one standard deviation in the teacher quality distribution, you increase student scores by about half this much. And remember that the principal influences every child in the school. And so if you could actually, by getting a better principal, increase student achievement by 1/5 of a standard deviation in a year, you could eliminate a lot of social inequalities very quickly. But this seemed to us to be quite large and likely, almost certainly driven by combining any real effect of the principals with other differences among schools. Now, we quickly do a few sensitivity checks, and that is we try to do something about the random measurement error. That's what the shrinking means. And the reweighting is this idea of comparing kids with other kids who start in the same place. And what we find, the 0.207 is taken from the previous table. When you shrink to account for random measurement error, almost nothing happens. And that's because, unlike for teachers, for whom you may only have 20 or 25 or 30 kids with test scores, for principals, even in the smallest schools, there's a couple hundred observations, almost always. When you reweight, you do get larger estimates of the variation of principal effects, and this is consistent with this concern that you're not counting the effectiveness of principals with high-achieving kids very well. And what we're going to do from now on, since the reweighting tended to make things bigger, and we wanted to proceed more conservatively, we're going to use the original unweighted data. The next thing we do is we present these models with school fixed effects. And the models with school fixed effects now are comparing principals only with other principals who served in the same school or connected group of schools that share principals in common. And if you go to the bottom row, we estimate this twice because it's a slightly different sample. The first time with no school fixed effects, and we end up with 0.224, which is almost the same as in the other one. And when you add the school fixed effects, you end up with 0.11. So now we've cut the variation that we get of principal effects in half. Now another thing to look, I think that's interesting and consistent with our prior views, was that as the schools become more poor, the variance in principal quality is rising. So in the lowest poverty schools, it's 0.077, and in the highest poverty schools, it's 0.138. Now these fixed effects have a potential problem because they're going to capture differences in the quality of the student cohort, in errors that are common to all students in a year, and other unobserved factors, and they're going to be included in our estimate of the variance in principal quality. Because when you do these models with fixed effects, or these semi-parametric models, even if the unobservables or the omitted variables are not correlated with true principal quality, they're still going to inflate the estimates of the variance. So the individual fixed effects of the principal, those can be unbiased, but your estimate of the variance is still going to be too large. So that's why we want to concentrate on these turnover estimates. And these estimates, I want you to think about having 4 years of data on a principal. And you can compare the variation in student performance from the first year to the second year. So if you take the second year average gain minus the average gain in the first year and square it, you get some measure of the difference between the first and second year. And then you could do the same thing between the third and the fourth year when you have the new principal in the school in both of those years. And those two measures would give you measures of your fluctuation in test scores from year to year in periods in which you have the same, in periods in which the principal is not changing. And then essentially what we do is compare that to the second versus the third year. And that's a period in which the first principal leaves after the second year, and so the third year you have a different principal. So when you compare the third year's gains minus the second year's gains and square them, that's a period in which you're comparing how well the schools did under two different principals. And our idea is that if we observe much larger fluctuations during transitions of principals than we do within principal spells at schools, that's indicative of the fact that principals are having an effect on the schools. Yes, Ismail.